Let us move to Edexcel IGCSE Chemistry in June 2025, paper 2C. Starting with the question 1. So this question is about elements, compounds, and mixture. So the box gives the names of some substances. Choose a substance from the box to answer each of these questions. Give the name of a compound. So it will be water. Give the name of a mixture. So it will be petrol. Give the name of diatomic molecules. So it will be fluorine. Give the name of a metal element, calcium. Then question B, name the technique used to separate crude oil into fractions, so it will be fractional distillation. And give one use of kerosene fraction, so used for aircraft fuel. Question 2. Magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen. The hydrogen is collected in a gas cylinder. The reaction is exothermic and magnesium is in excess. So question A states what is meant by the term exothermic. So it is a reaction in which the heat energy is given out to the surroundings. Question B. Complete the chemical equation for this reaction. Okay, so we will have magnesium chloride, which is MgCl2 and H2. Question C. Draw a sketch graph to show how the volume of hydrogen changes with time until the reaction has finished. So initially, the reaction will be fastest, but as the time goes on, the reaction will become slower and the volume of hydrogen will constant. Question D. Explain why increasing the temperature of the hydrochloric acid affect the rate of the reaction. Refer to collision theory in your answer. So first one is that rate of reaction increases. And then particles have more kinetic energy. And then there will be more collision per unit time. And the last one is more successful collisions. Question E. Draw a reaction profile diagram for the reactant showing delta H and activation energy. So this is the reactant, which is Mg plus 2HCl. And since this one is an exothermic reaction, right? So the product will be here. Okay, so it will be like this. Okay, and then this is magnesium chloride plus hydrogen. The activation energy will be here. And enthalpy change will be here. That's it. Question 3. This question is about group 2 elements and their compounds. Question A. A sample of magnesium contains 3 isotopes. So I state in terms of subatomic particles. What is meant by the term isotopes? So isotope is the same element with the same number of protons. But different number of neutrons. Question II. Calculate the relative atomic mass AR of magnesium. Give your answer to one decimal place. So AR equal to the 24 times 76.5 plus 25 times 10.5 plus 26 times 13 divided by 100. So it is equal to 24 times 76.5 plus 25 times 10.5 plus 26 times 13, which is equal to 2436.5 divided by 100. So it is equal to 24.4. Question B. Which of these compounds is an insoluble solid? So the answer is calcium sulfate. Question C. Magnesium oxide is an ionic compound. The diagram shows the atoms of magnesium and oxygen. Draw diagram to show the structure of each ion in magnesium oxide. Include the charge on each ion. So we have nucleus. Then we have first shell and second shell with the 2 positive charge. So we have 2 electrons in the first shell and 8 electrons in the second shell. So this is for magnesium ion. And then for oxide, we have nucleus. And we have first shell and second shell. 2 electrons in the first shell and 6 electrons in the second shell. 8 electrons. And then the charge will be 2 negative. So this is the charge for oxide ion. Question D. The table lists some substances and show which substance conduct electricity. So we have water cannot conduct electricity. Solid magnesium chloride cannot conduct electricity, and aqueous magnesium chloride, it can conduct electricity. So explain this observation, refer to structure and bonding into your answer. So So first one, water is a covalent compound. Okay, it does not have a delocalized electron, which is free to move. Okay, for solid magnesium chloride, is an anionic compound, but ions does not free to move. Ions do not free to move, and aqueous magnesium chloride ions are free to move. Okay. Question E. A concentrated aqueous solution of magnesium chloride is electrolyzed. Chlorine form at the positive electrode. So give the half equation for the reaction at the positive electrode. So we have chloride ion, and it will lose electron to form chlorine gas. So put 2 here. And then next one, give a reason why this reaction is classified as oxidation, because it loses electron. Question 4. This question is about the reactions of ethanol and ethanoic acid. Ethanol reacts with potassium dichromate to form ethanoic acid. Name the other reagent needed in this reaction. So we need sulfuric acid. Next, state the color change that occurs when ethanol reacts with potassium dichromate. So the color will change from orange to green. Question B. Ethanoic acid reacts with solid sodium carbonate. Complete the chemical equation for this reaction. Okay, so we will get sodium acetate plus carbon dioxide plus water. Next, state 2 observations seen in this reaction. So we will see bubbles of carbon dioxide gas, and another one is sodium carbonate disappear. Question C. A student prepare the ester ethyl ethanoate by reacting ethanol with ethanoic acid. This is the student's method. Mix equal amount of ethanol and ethanoic acid in a boiling tube. Add a few drops of concentrated sulfuric acid. Place the boiling tube in hot water bath for several minutes. State the role of sulfuric acid in this reaction, so it acts as a catalyst. Next, state why the student heats the mixture in a water bath instead of directly with the Bunsen burner. Because ethanol can ignite. Next, state how the student would know that ethyl ethanoate has formed. So he will get a distinctive smell. Next, draw the display formula of ethyl ethanoate. Okay, so I have CCO, then C and C. Let's start the bond. This one is a double bond. O. And then I will add hydrogen. Question 5. A student does a titration to find the concentration of a solution of sulfuric acid. So this is the student's method. Fill a burette with a sulfuric acid and record the reading. Transfer 25 cm cube of potassium hydroxide solution to a conical flask. Add a few drops of methyl orange to the conical flask. Place the conical flask on a white tile. Then swirl the flask continuously while adding sulfuric acid from the burette. Keep adding sulfuric acid until the endpoint has been reached. Record the rough reading at the endpoint. So name the most suitable pieces of apparatus for measuring 25 cm cube of potassium hydroxide solution. So we will use pipette. Next, state why the student places the conical flask on a white tile in order to observe the color change clearly. Question B. The diagram shows the final burette reading. The initial burette reading is given in the table. Complete the table, giving both values to the nearest 0.05 cm cube. So final burette reading is around 32.1.2, 32.5, no, sorry, 32.25. Okay. So the volume of sulfuric acid will be equal to 28.1. Then question C. The student repeats the titration for more accurately 4 times. The table shows their result. Concordant results are those within 0.2 cm cube of each other. So place ticks in the table to show which results are concordant. So 0.2, so starting with this, and this. And then use the concordant result to calculate the mean volume of sulfuric acid added. Okay, so we will have 27.4 plus 27.3 plus 27.35 divided by 3. So we have 27.4 plus 27.3 plus 27.35 divided by 3 is 27.35. Question D. Another student also does the titration. The student uses 25 cm cube of potassium hydroxide solution with a concentration of 0.5 mole per liter. The mean volume of sulfuric acid added is 26.5 cm cube, and this is the equation for the titration. So calculate the concentration of the sulfuric acid. So we have, according to the formula, mole equal to concentration times volume divided by 1000. So we have concentration of the potassium hydroxide equal to 0.5 times volume, which is 25, divided by 1000. But we have 2 here in the equation, so I have to multiply with 2 here, equal to the mole of the sulfuric acid. So we have to find the concentration, right? So concentration of sulfuric acid times volume of sulfuric acid, which is equal to 26.5 divided by 1000. So 1000 can be cancelled out. So the concentration of sulfuric acid will be equal to 0.5 times 25 divided by 2 times 26.5. So it will be 0.5 times 25 divided by 2, and then divided by 26.5, which is equal to 0.24 mole per liters. Next one, the student repeat the titration without the methyl orange indicator. They add exactly 26.5 cm cube of sulfuric acid to the potassium hydroxide solution. Describe how the student could obtain pure dry potassium sulfate crystal from the reaction mixture. So first one is heat the solution until crystals form. And then allow it to cool. Next is filter the solution to obtain the crystal, and then the last step is leave it to dry. Question 6. Hydrogen react with iodine vapor to form hydrogen iodide. So this is the equation for the reaction. Okay, here's the test for hydrogen. Quickie pop test. Next, state what the symbol represent. It represents the reversible reaction. Question B. In a sealed container at equilibrium, the reaction conditions are 500 degrees Celsius and 2 atm. The temperature of the reaction mixture is increased to 600 degrees Celsius, but the pressure is kept at 2 atm. Explain the effect, if any, on the yield of hydrogen iodide at equilibrium. So this reaction is an endothermic reaction. So yield on hydrogen iodide. So yield of hydrogen iodide increase because the equilibrium shift to the right. Question II. The pressure of the reaction mixture is decreased to 1 atm, but the temperature is kept at 500 degrees Celsius. Explain the effect on the yield of hydrogen iodide. Okay, so let me count the number of mole here. So it is 1 plus 1, which is equal to 2, and the right hand side equal to 2 as well. So no effect on the yield, because the equilibrium does not shift. Question C. An excess of hydrogen reacts with 50.8 grams of iodine. At equilibrium, the yield of hydrogen iodide is 80%. So calculate the volume in cubic centimeters of hydrogen iodide produced at RTP. Give your answer in standard form. Okay, so let me find the number of mole of iodine first. So it is equal to mass divided by 2 times 127. So it is equal to 0.2 mole. Okay, then the number of mole of hydrogen iodide will be equal to, it is 1 to 2. Okay, so it will be equal to 0.2 times 2 times 80% divided by 100. So the mole of hydrogen iodide will be equal to 0.32 mole. Then volume of hydrogen iodide will be equal to 0.32 times 24,000, which is equal to 7,680 cubic centimeters. So if we make it into the standard form, it will be equal to 7.7 times 10 to the power of 3.